Thanks, everyone. Thanks for coming on a Saturday to talk about reading minds with natural language processing. I'm at the Law, Economics, and Data Science group at the Department of Social Sciences, and we work at the intersection of social science and data science. And an important issue in this is to understand what people value, what people think about, how people reason, what are the narratives that people use to persuade each other and persuade themselves. And this is an area where these new developments in natural language processing and computational linguistics can be really exciting. So previously, how would you read minds? One would be telepathy. I think we're having trouble getting that off the ground. Something that you might be intuitively might make sense is brain scan, so you can do functional MRI to look at what areas of the brain are lighting up. This is pretty nice, but also has some limitations. But today we're going to talk about something maybe a bit more concrete, natural language processing, what people say, what people write, what people read. To start off, we'll talk about the technology that in the applications that I'm using, how we do this. There's this new set of algorithms and approaches to natural language called word embeddings or text embeddings or document embeddings. And I think what's new about these is you can extract not just explicit mentions of particular people or organizations or arguments or emotions or positive or negative. You can also get at implicit associations. And I think when we use the perhaps provocative phrase read minds, we don't want to just get at what people are intentionally getting across, but also what is more subconscious or more unintended. And so this is where implicit associations come in. In terms of the applications, I'll get at three applications of this, and I'm using this provocative term, read minds, and you might disagree with that framing. I'm happy. I'm fine with that. But we can discuss how close it is to reading minds, I hope, and how would we get to the next step of reading minds if this isn't there yet. The three applications we'll talk about is the use of economics reasoning, so economic analysis, like trying to understand how judges are reasoning towards their decisions. The second is in expression of emotions or emotional intensity. Thank you. And the third is on gender attitudes and gender stereotyping. So these are kind of these three examples of what people value and how they think that we can get at using natural language processing. So I'm going to go through these different projects and applications as we go. We have quite a lot of time, so if there's questions throughout, I'd be very interested and happy to talk about them. Or if you just disagree with something, I'd be happy to hear about that too. We could talk about it. But then we'll have plenty of time at the end for Q&A and discussion. So word embedding is this technology that you might have, if you've taken any NLP classes recently, would have heard about it probably. It's this computational linguistics set of tools and algorithms that put words and phrases and documents into locations in a geometric space. And you can think of this almost like it has a lot of the same properties as a physical space. It's not just 2 or 3 dimensions. It could be 256 dimensions or 768 dimensions. But a lot of the intuitions about space that you get from 2 or 3 dimensions apply in these geometric spaces of language in the higher dimensions. And you can, it turns out that our intuitions about directions in space can encode semantic meaning, where you can see some examples here, such as the same shift in the space that goes from man to woman is going to be the same shift in the space from king to queen. And so you can see that this arrow here is getting at something like gender, like a male to female dimension. Similarly, things like verb tense, so going from swimming to swam or walking to walked, or from country to capital, these types of things that are really intuitive and semantically interpretable and cognizable by humans are encoded in these directions in this word embedding space. And so we're going to take advantage of this really intriguing encoding of analogical relations in word embeddings to get at the implicit and explicit associations that people make in their spoken or written text. So the first application of this is the use of economics reasoning in judicial opinions. So this is, if you're curious about the background, we can talk about it more in the Q&A, but this is this kind of classic dichotomy in legal theory, let's say, where should decisions be made based on moral principles or justice, or should they be done based on efficiency and reducing costs? And there is a philosophy or a philosophical approach to law that's mainly focused in the U.S. Using economics to make judicial decisions. And so to get at that, we start off with this lexicon of phrases to identify economics-related language in the law that's like including capital, costs and benefits, deterrence, efficiency, externalities, marketplace, transaction costs. These are the types of things that if you were doing a course in law and economics, for example, you would learn about these concepts. And the motivation for this research is whether judges actually go to some coursework in economics. And so we want to see, do these phrases, do these concepts get into their judicial opinions after they take economics courses? And we can't just count these phrases. That doesn't work very well because when you look at these decisions, they don't use the phrases exactly. They often talk about them more implicitly. They use related synonyms and things like that. And so this is why we need a word embedding approach. So rather than just counting these phrases, we construct a vector in this word embedding space that I mentioned a second ago that corresponds to this collection of words related to economics. And so you can imagine in the same way that we had like a direction for gender in this space, there's like a direction for economics. And then each case that a judge writes, so they write these long opinions. It's a common law system in the United States. They write these long opinions where they're explaining why they made a decision, and we can see how much they use economics reasoning by where the case locates along this economic spectrum constructed from this word embedding dimension. So to validate that this works, we first looked at some of the phrases or the words and phrases in the language that are most correlated with this economics dimension, and they're quite persuasive. I think they're kind of intuitive that words like efficiency and costs and markets, profitability, utility, economy, incentives, these are the types of words that you'd associate with economic reasoning. And so you can imagine that the judges that score highly on this use of economics reasoning measure, they're using more language like this. But the nice thing about embeddings is that it's not just counting words like doing a search. It's really looking at it's weighting across all words in the case and getting at these even implicit uses of economics. And so if you look at some of the example sentences that score highly on the metric, they're also quite persuasive. So like the one on the top is one of the highest scoring sentences, and it's really an example of a judge using economics reasoning. They're talking about oligopolies, profit maximization, economic interests, but also there's mentions of second best, firm, consumer surplus, willingness to pay, economic efficiency gains. These are all if you've taken Econ 101, you recognize these phrases instantly. But they actually weren't in the lexicon. So our word embedding model learned these implicitly from this language space. So as I mentioned, the motivation for of analyzing economics reasoning in these opinions was that there was this economics course for judges. This is from the 1970s, I think, or early 80s, where for 3 weeks, 19 federal judges from around the country took a grueling 6-day-a-week course in economics, with classes starting at 9 a.m. and sometimes ending at 10 p.m. So what happens when you have this 3-week course for judges and you drill into their heads economics for 3 weeks? Does it actually work? It turns out that the answer is yes, it does work, in the sense that after attending this economic summer camp, which is at this spot in the timeline, you see this significant increase in the use of economics language as measured from this word embedding score. So according to our measure, we can look inside the judges' heads and see they're using more economics reasoning as expressed in their judicial opinions. So you might think, well, they're just using the more language because they picked up a few phrases, a few vocabulary words on the course. But it's not just that. They actually start changing some of their economics-related decisions. After economics training course, the judges tended to vote. They tended to vote against regulatory agencies. So they voted against labor. They voted against environmental protections. And something that was a bit more surprising is that they were also harsher on crime. So judges that attended this economics training course, they started using more economics reasoning, but they also started giving longer prison sentences. So this is maybe a bit, it may be counterintuitive at first blush, but actually when they were learning about criminal law in this course, we saw that it was about deterrence. So they were learning that an incentives approach to criminal law says, well, if you impose a longer criminal sentence, then people will commit less crimes. And so this is what economics reasoning applied to criminal law will achieve. The second application of reading minds with natural language processing is looking at emotionality or emotional intensity. So we have this quote from this recent book by Drew Weston, where in politics, when reason and emotion collide, emotion invariably wins. So this is this motivation for how do we detect emotionality? How do we measure it in political discourse? So we go back to our word embedding approach, where, remember, we had those pointers in the space for gender, or we had the direction in space for capitals of countries, or for economics reasoning. In this second application, we have a direction in the space corresponding to emotion, and another one corresponding to reason or cognition. And this is what these directions look like. On this side, these are the emotional words here on the left, like kind of positively themed emotion words and negatively themed ones. And on the right, we have the more cognition or reason or deliberation or logical words, both the positively toned ones and the negatively toned. And so when you look at this, you get an idea that, well, this dimension in space, where I'm trying to look at a document and say, is it on the emotion side or the cognition side? Or I'm listening to a speech. Is it on the cognition side or the emotion side? This is the type of language that's identifying that. And in the data, when we're trying to score these speeches, and we have a bunch of political speeches also from the U.S. Congress. It's really it's constructing an affective to cognitive or emotion to reason vector in space, and it's really getting the correlation between the vector for a document, a speech, and this emotion vector. And it's it's from trigonometry, right? It's just the cosine of the angle between these two vectors will give us the relative emotionality of a text or a speech. So if we apply it to the U.S. congressional speeches, we can get these types of examples. So I filtered on the abortion topic, the reproductive rights topic, and you can just quickly look at some of at these snippets of speeches and guess which one of these is the emotion one and which one of these is the cognitive one. Even though the topic is the same, you can really see this big difference in framing. So beyond these qualitative validations where we looked at the correlated words and then looked at the differently ranked speeches, we also made a big sample of sentences according to our metric and asked, we did a crowdsourcing task where we asked people, which of these sentences is more emotional? Which of these sentences is more logical? And we found that our embedding-based score for these sentences based on the word embeddings, it agreed with human judgment over 90% of the time. So this is giving us some reassurance that our NLP-based measure is really capturing emotionality or emotional intensity. So we use this I have this paper with Gloria Gennaro where we use this for a number of analyses. But one that I think is really interesting is to just look at how this has changed over time. And we have this data from the congressional record, all the speeches, which goes back to the 1850s. And you can see that emotionality was pretty, it kind of stayed pretty constant and low, just increasing quite slowly up until around the 1970s. But since then, it shot up a lot. And you can see that it also kind of spikes during wars, which I think makes sense, like kind of patriotism that makes people emotional. But really, the interesting thing is interesting question is what happened here. And we noticed this. We were kind of looking at the history around this time, and we noticed that this is exactly the same time where Congress went on television. So C-SPAN is this cable channel, TV channel that where congressmen they can talk directly to their constituents because all of their speeches are televised now, and I think it's kind of intuitive that once you start talking to voters, to normal people, rather than to other politicians, other congressmen, there's this reward for being more emotionally bombastic or more populist. And so we can see that in the data. We also compared the level of emotionality by topic. So this in panel A, we're just comparing the topics. So like national narrative, that's like talking about the American dream or patriotism, that's the most emotional topic. It's very intuitive. Whereas like procedure, kind of these more boring topics has the lowest emotionality. So that's this ranking is pretty intuitive. Something that I think is quite interesting is the partisan difference. So the Republicans are the right-wing party, Democrats are the left-wing party in the U.S. And the topic where Republicans are most emotional relative to Democrats is fiscal policy. So that's taxation and redistribution, which I think it's very interesting and kind of intuitive from a political economy perspective that the party that wants to protect inequality, preserve inequality, they have all of these emotional arguments and emotional appeals to protect that. We also applied it to some tweets, and this is also, we're just starting this, but I think it's also will be very interesting to use this on social media and other corpora. So these are the hashtags that are most emotional. So you see things like pro-life, March for Our Lives, National Day of Prayer, and then you see these really kind of technical political topics for the reason, the most cognitive tweets. So the third and final application that I wanted to talk to you about, and then we can have a discussion, is gender stereotyping among U.S. judges. So this probably doesn't make the news over here, but in the U.S., sexism in the judiciary is a pretty well-recognized problem, especially in recent years. And if you look in the news, there's many examples of judges mistreating their clerks or their colleagues or female litigants in their courtroom. And this is anecdotal evidence. To get at this statistically, you'd want to build a data set, right? And for example, there's a few papers in political science where they read through, for example, a few hundred decisions and coded them as favoring women's rights or not. But this doesn't scale well. In our data set on the U.S. Circuit Court opinions, we have 400,000 cases. If you include the lower court cases in that, we have over 1 million. And so hand coding those decisions, reading each case takes 30 minutes or an hour or so of your time. So there would be no way to actually produce a data set on this by manually reading them. And if you wanted to look at something that's like maybe a little more subjective or implicit, such as gender stereotyping, then even with hand coding, you wouldn't be able to do it. And so we go back to our mind reading tool, word embeddings. In this paper with Daniel Chen and Ariana Ornaghi, we analyzed this gender career stereotype, which is kind of this classic stereotype from the psychology literature, where men are associated with the office and the career, and women are associated with the home or the family. And we can't just, when you read the judicial opinions, they don't explicitly say this, right? They don't say, women should stay in the home. They don't like make these explicit bias statements. But we can use the word embeddings to see how these concepts are correlated. And this is just revisiting the picture that we showed earlier, that we can capture this gender dimension as the average of the male words minus the average of the female words, just getting at this translation. And similarly, we identify a work to family dimension as the average of work words and the average of family words. And we just say, for stereotype judges, the male to female dimension is highly correlated with the work to family dimension, as measured by the cosine of the angle between the vectors. And so, but if those vectors are orthogonal, if they're perpendicular, that means the judge doesn't have any stereotype. And so we can really kind of just compare judges along this scale. How correlated are these vectors, as measured from their judicial opinions that they write and publish? So if you look at some of just descriptively, at some of the language that is correlated with gender in the U.S. judicial opinions, you already get an idea of this. So we actually just looked at the adjectives in the corpus that are most associated with sentences with a male pronoun or sentences with a female pronoun. And you see these, quite, I would say, a bit unsettling differences in gendered language. So for male, you see like understanding, active, intelligent. But for females, you see irritable, hostile, rude, immature. So this is just overall, but it already gives you a sign that there is this arguably a gender bias in how judges are talking about gender. So when we make this stereotype use measure based on word embeddings by judge, we see some intuitive correlations. So male judges have higher gender stereotype use. The older judges, the judges from earlier cohorts, have higher gender stereotype use. And if you compare judges that are on the same court at the same time, but with the judges that have more daughters relative to sons, they have fewer gender stereotypes. So I think that's kind of interesting, in general, but it's also, from a social science standpoint, it's nice because the gender of your kids is random. It's 50-50, right? And so this is a natural experiment. So you might also ask, well, is this just, they're just talking about the world or they're reflecting something else? Maybe it doesn't matter to their decisions. It turns out that it does. So the judges that are more stereotyped relative to their colleagues tend to vote against expanding women's rights. So in reproductive rights decisions, discrimination, things like this, the more stereotyped judges in their language, it's also reflected in the direction of their rulings. And this holds even after controlling for their political party, other sides of conservatism. It really seems like there is this gender rights segment of ideology. It also matters for how they treat their colleagues. So, the judges in the U.S., they work on these collegial courts, and they're interacting with their colleagues. They're also interacting with lower court judges. And we find that they're not only likely, the judges that are more stereotyped, they cite fewer women, like they're citing each other's cases, and they also are more likely to reverse them, to reject the lower court decisions of female judges. So this is, of course, policy relevant because women are half the world's population. So to conclude, how to read minds, we talked about telepathy, brain scans, natural language processing. I'd like to hear your views or your thoughts about, is this mind reading or not? And if it's not, how do we improve it to get there? And also, what else can we do? Are there some other technologies, perhaps in NLP or other things from artificial intelligence, for example, that are coming out that will help us read minds even more? Thank you, and I look forward to your questions. Please.
For your question, in the end, if you think about mind reading is nothing else than predicting what the other person would say. So it's like natural language processing. You predict what the other person might behave or might say. In our sense of mind reading, it is the same.
That's an interesting point. Yes. So if we think about in my framing of natural language processing in this talk so far has been getting at these associations in text or these dimensions of meaning. But if we think about mind reading as a prediction about what someone will say or what someone will do, then that's getting at perhaps more into kind of machine learning, machine classification, supervised learning models. And you can imagine if you can predict how a judge will decide in a case, for example, you're kind of getting into their head and reading their minds. So one of the advantages, but also limitation of the word embedding approach is that it's an unsupervised language model. But if we start using these more predictive language models to predict what language will come next or what decision will arise after reading the inputs to a judge's decision, you might be able to read their minds in a different way. So I think that using supervised learning would be a nice alternative.
I have another question.
Yes? Yes, that's interesting. So I showed you this distribution by gender of male and female, but actually after adjusting for the age of the judge and the gender of the judge, there was no difference between the more conservative and more liberal judges, at least as measured by their political affiliation. So that was something that was actually quite surprising to us, is that the more left-wing, like socially liberal party, it didn't come out in their language. So I think that this is despite the fact that the more left-wing party, of course, they're more likely to be socially liberal on their decisions about like reproductive rights and women's rights and things like that. But even after controlling for that, there's an additional effect of this gender stereotyping. So I think that's actually, in some ways, what's important about this is because it's showing that it's not just a political preferences. There really is this additional gender-oriented ideological dimension. Yeah, thank you. Yeah, a great question. the approach that we used in this paper, where we trained a separate word embedding model and got at the correlation of the vectors, it actually requires 1 million tokens, so a million words. So it didn't actually work for a lot of the judges in our corpus because you needed so much text. You really needed, at least like a few hundred of their opinions to be able to make it work. The other approaches that I mentioned on the emotional intensity and the economics reasoning doesn't need as many. So you could actually make those measures at the document level or even at the sentence level. But in follow-up work to this, where there are some, I don't have time to get into the technical specifics, but there actually are some new approaches that are, I would say, a bit more experimental, where you could try to make this using you wouldn't need very many documents. So I think this would be important to do, to actually see, can you look within the same judge of how do their attitudes evolve over time, or even does it vary a lot even across cases? If they have a female colleague, does that influence what language they use? With this approach, we're not able to do that, but this is one of the natural follow-up studies to do. Thank you. Yeah.
Now it's working. Okay. I just wanted to ask, if you want to find out the most about a person, for example, in the emotionality of speeches, doesn't a lot get lost if you just analyze the text and, for example, not the tone of the voice during the speech, or other data points that you could use to predict that more accurately?
Yeah, totally. That's a great idea. So in the case of the judges, you wouldn't be able to do that, right? Because the judicial opinions that we're analyzing for the economic analysis or the gender attitudes, it's really just a published document. But for the congressional speeches, I think that's a really nice idea. That especially for the more recent years, you could actually get recordings, perhaps even the videos. So I think that at least as much information about somebody's preferences and values and attitudes comes through in how something is phrased, right? Just like the tone of voice or the emotional intensity from volume and things like that. At least as much as what's actually in the written language. So I think it's another natural follow-up. So the other reason we didn't do it in the paper that I showed you is that we don't have recordings going back to the 1800s, right? So you wouldn't be able to make this long. That's a nice feature, is that we can look for 150 years, how has this been changing over time? But for the most recent years, since for the last 50 years or so, there's actually recordings of everything, and I think that getting at how are they shouting at each other, or there's many questions to ask there. So I like that idea.
Thanks.
Yeah, so I was just wondering, on the topic of reading minds, that there has been a technique of EEG which try to read brain waves and try to detect what person thinks, and is able to control, for example, robotic movement in a very simplistic level. So I was wondering if there is any research done in the area of, for example, monitoring the EEG of someone who's doing a speech or writing a sentence, like an inter area between natural language processing and the EEG.
Yeah, I think it's a fantastic idea, and we're not really. So I think that there was some early work using fMRI, functional MRI, and looking at when having people listen to stories and things like this, and there were some really exciting early results. But fMRI has a lot of limitations in the the spatial localization of the activation, as well as it's actually not very fast. Or it's not very frequent. You can only get a scan like every few seconds. Whereas EEG is great because it has really high frequency of scans. So you can match it to specific words that are being mentioned, I think you could I bet you could do like lie detection and things like this with it, and that's getting close to reading minds. Yeah, you should do that. I think that sort of whole research program doesn't really exist yet, but I think it will be really impactful. So I think it will be great.
So many questions. Yeah, let's go to you first.
I have a question.
Yeah, I can hear. Yeah. Mm-hmm.
About you weren't able to look at the judge changes his opinion over time.
Yep.
I am wondering if there's a great difference between judges from like 20 years ago to the judges right now, because there was a lot
Yep.
change in the past year. So could you mention this?
Yes, yeah, we did look at that. So, or how we did it is, we looked at, we compared judicial opinions from like within the last 20 years versus like the 20 years previous, for example. There were differences there, but actually what made an even more big difference is the cohort of the actual judge. So within the same court at the same time, the older judges, so like if a judge is like kind of 20 years older, they were using many more stereotypes. So you can kind of like, it's like the more traditional way, like these more traditional mores, right? It came through in their judicial opinions. So there has been this evolution over time towards more liberal, more egalitarian language around gender. But so we can do that. We can compare like kind of over longer time periods. But it would be nice to be able to say, year to year, for example. That still has not been done. Yeah. Was there a question up here?
The examples that you showed was analyzing language produced by people who are trained to use it carefully.
Yeah.
You also analyze language produced by people who haven't been trained.
That's a good point. I think that's actually kind of an open question. So I showed, we've done a little bit on Twitter. So like this is like kind of an example of that. I think for more recent language, you can do this with social media, right? Which I think will be very exciting. There's many potential analysis to do. In the more historical analysis that's going back to 100 years or something, we just don't have records of what people were saying back then, unfortunately. Our record of speeches and writings from like say 100 years ago or 150 years ago, it really is only context like you're saying, where people who are writing carefully and are professional and trained. Even like diaries and things like that, there aren't very many that have been recovered, and it's going to be a selected sample in any case. As you can see here, these same tools could be used for more layperson language, more natural language, less professional language, and if anything, I suspect it would work better, right? Because judges, for example, have a really strong incentive to be very fair and dry and not very expressive in their writing styles. So the fact that we still see it is perhaps surprising. So for if we're looking at Twitter or Facebook posts, things like this, I suspect that you'd be able to identify that even better. Yeah.
Super, thank you. We're sadly out of time.
Yeah.
You can always ask him questions. He's at ETH. You can find his name in the database.
Yes.
Thank you very much for your lecture.
Thanks, everyone.